Have you ever stared at some data and just wondered, is that difference I'm seeing a real thing or is it just, random luck? Well, today we're going to pull back the curtain on a super powerful tool called the Z-test, which helps you answer that exact question. Right? Think about it. Maybe you're comparing two marketing campaigns. One did a little better than the other. But is that difference big enough to bet your budget on? Or could it just be a random fluke? That's exactly the kind of question that tools like the Z-test were invented to solve. So, how do we tackle this problem? Well, think of statistics as having this huge toolbox. And inside, there are all sorts of different tests, and each one is specially designed for a specific job. Let's take a quick peek inside. And when you look in that toolbox, you'll see all kinds of names: Z-test, T-test, chi-square, ANOVA, a whole bunch of them. Each one is a specialized tool. But today, we're going to get laser-focused on one of the most fundamental tools in the entire kit, the Z-test.
Okay, so with all those options, how do you know when the Z-test is the right tool for the job? Well, it actually comes down to a super simple 3-point checklist. If you can say yes to all three, you're good to go.
All right, here it is. First up, your goal has to be comparing the average or the mean of a group or maybe a couple of groups. Second, and this one is a biggie, you can't skip it, you must already know the standard deviation of the entire population you're looking at. And third, your sample size needs to be large. All three of these have to be true, no exceptions. I know what you're thinking. What in the world counts as large? Thankfully, it's not as vague as it sounds. In the world of statistics, the magic number is usually 30. If your sample has more than 30 data points, you're generally considered to have a large sample. If it's smaller, you'd probably reach for a different tool, like the t-test. Okay, so let's say you've checked all the boxes. Your sample is big, you know that standard deviation, and you're comparing means. You're ready to go, right? Well, almost. There's one more choice you have to make, because the Z-test comes in two main flavors. And luckily, this is super straightforward. The one-sample Z-test is all about comparing your little group, your sample, against the big picture, the whole population. Then you've got the two-sample Z-test, and that's exactly what it sounds like. You're comparing two different samples directly against each other. So let's drill down on that one-sample test for a second. The idea here is actually pretty cool. You're basically just measuring how far away your sample's average is from the known average of the entire population. The formula then helps you figure out if that distance is big enough to be significant, or if it's so small it could have just happened by chance. Now, the two-sample test is for when you're looking at two totally separate groups. The whole point here is to see if the difference you're observing between their averages is a big deal or if it's just statistical noise. The test basically weighs that difference against how much variation you'd normally expect to see. Okay, that's enough theory, right? Let's make this real. How does this stuff actually get used out in the wild? Let's walk through a couple of simple, practical examples. So for a one-sample test, imagine you want to know if students at one specific college are outperforming the university as a whole. You could take the average test score of, say, 100 students from that college. That's your sample. Then you'd compare that to the known average score for every student across the entire university. That's your population. See? Sample versus population. It's a textbook case for a one-sample Z-test.
All right, now for a two-sample scenario. Let's say a company wants to know if there's a difference in the average performance ratings between its male and female employees. They could take a random sample of male employees and another separate sample of female employees, and then compare the average ratings of those two groups. Notice the difference? You're not comparing to some bigger known population. It's just sample versus sample.
We have covered a lot of ground, I know. So let's just pause for a second and boil it all down to the absolute must-know takeaways. If you remember nothing else from this, remember these three things. So here's the bottom line. What's a Z-test for? Simple. It's to check if a difference between averages is the real deal. When do you use it? Only when you have a big sample, more than 30, and you already know the standard deviation for the whole population. And finally, which one do you pick? Easy. A one-sample test for a sample versus a population, and a two-sample test for a sample versus another sample. That's it. And that leaves us with one last really important question. See, when you run the test, it spits out a number. It's called a z-score. But what does that number actually mean? How do you take that score and turn it into a confident yes or no decision? Well, that is the key to unlocking the real power of all this. And it's the perfect place for us to pick things up next time.